Hello everybody, this is Chris Mackey. Welcome back. This is your 7th tutorial video on Honeybee energy simulation, and in this one we'll be looking at importing results. This is if you guys remember in the last one we just set up a simulation and ran it, and in this one now we're going to be importing the results back into Grasshopper and using them to do cool things, and really understand what happened in this energy simulation. So first, well, there was something I probably should have explained in the last video, but you get two things out of this component, and one of them is this IDF, and that's a file that this Energy Plus engine understands. It's a text file. But the thing is, this file has all the information, all the properties that we've been assigning to these zones as we've been building up in the past few videos. And you can see actually there's a component that allows you to actually read the IDF back into Honeybee. Into Grasshopper. And so if you drag and drop this, I mean it's this import IDF component. If you drag and drop that onto your canvas and you hook up the IDF file, you'll realize that you can actually convert your IDF back from the text file format into Honeybee zones. And you can see, well, it's previewing those as our kind of standard Grasshopper red. But these Honeybee zones, I mean, they have the same properties as the zones that we checked in, and you can use this to double check and make sure that your energy simulation ran correctly. So if I turn the preview off there, and we hook up the Honeybee zones here to the same thing, we can actually see what was run through the Energy Plus engine. And make sure that everything was okay. And it looks like, yeah, that all the geometry looks relatively good. All our windows came over, and really you guys should actually probably have done this. I should have done this before I ran the energy simulation, because all you need to do is write the IDF and then you can check this out. And then you're sure that the geometry is good before you run a whole simulation, which can sometimes take a very long time. Alright, so you guys understand what the IDF is and how it comes back in. I think, for now, for this video, I think I'm just going to put our zones back from beforehand in. And we're going to spend the rest of the video just looking at the CSV results file, which is the other one of these two, this bottom one, that you get out of that energy simulation that we ran. Alright, well, it's taking its sweet time on my slow machine. Alright, here we go. So these are our old zones, exact same thing as what was put forward in the IDF component. And we're gonna kind of just delete that for now, and we'll delete that. So alright, so CSV address. In order to bring this in, just like the import IDF, there is a component that reads a CSV file and brings in the results. And you'll see that's under the 9 energy tab, like the import results, and there's a Honeybee read EP result. That's the component that we want. And if you drag and drop that component onto the canvas, you realize it's a pretty big one. And it's one that essentially takes our CSV result file address and spits out all this, these outputs that we requested. And you guys will kind of notice that that these outputs somewhat correspond to these outputs that we requested here at the start of the simulation. Alright, so now if I take the result file address and plug that into there, it's going to essentially parse through that CSV file that's at that address, and it's going to bring in the results just the results that we requested. And you can see once this finishes, I guess it can take some time if you have a lot of data in that CSV file, because we requested these outputs for 15 zones for every single hour of January. So you can imagine that's kind of a lot of data. Alright, we'll give it a few seconds here. Okay guys, I kind of fast forwarded a few seconds so that you guys didn't have to wait for me. But yeah, you see what comes in, it's just those things that we requested. So things related to the energy use, like heating, cooling, lighting, and plug loads and electric equipment. And the comfort stuff that we requested, right? Because we requested zone energy use, zone comfort metrics. And so we get things like the operative temperature, air temperature, radiant temperature. And you see, like, you can play around with the booleans on all these other ones and get different results out of your simulation when you run it. But for now, this is what we get. So what exactly is coming out of here? And I'm gonna repurpose this panel now. And let's say if we hooked up the heating to a panel here, and you'll see what we get is kind of a structure that you guys may be really familiar with from working with Ladybug. We get a header that tells us kind of what's there. So this is telling us that we get heating for energy for zone 0. And if you guys remember, so the zone 0 is the name of the zone that we saw earlier when we labeled it, labeled all the zones. And so this is essentially the heating energy in kilowatt hours for each hour of the month of January for that zone. And you'll see that this is not simply just a list for zone 0. You'll see that what this dash line means is that it's a branched list. So if we take the native grasshopper param viewer, or I was recently told it was called param, so I pardon my accent, but this param viewer, and you see actually we get essentially we get a branch for a list of hourly values for each of the 15 zones that are in our house model here. And so it's kind of like a large chunk of data, but we try and break it apart into these lists for you. And maybe one of the easy ways to do this, you guys saw me use the grasshopper explode tree. I'm searching for bang. That's the easy way to find it. But if you use the grasshopper explode tree and connect that up there, it'll give you a warning that that you have to match the outputs, and then you right click on this and you hit match outputs, and now you get each list for each zone. So this is our zone 0 heating, this is our zone 1 heating, and for each of these zones we're getting the values. And so you can start to parse through this what is usually just a big block of data that we get out of this simulation. And we can start to work with it this way. So let's see. I know zone 0 is the attic because that was always at the top of the list. And so we let's say we want to try and understand the energy use that's resulting from this attic roof space here. And let's say maybe we want to find the average, let's say the total heating energy in kilowatt hours for the month of January. So to do that easily, well, you guys probably already know from working with Ladybug that there's this component, this nifty little component that separates the data. It's under extra in the Ladybug tab. And if you drag and drop that separate data and you connect up the data for that zone, you'll see that it separates the header strings telling us what that information was from the numbers. And now that you have just the numbers separate, you can do all sorts of, you can use the native Grasshopper math components to do anything any sort of calculations you want with these. So let's say we wanted to total up all these kilowatt hours for the attic space. Well, we have a mass addition component in the maths tab of Grasshopper natively. And we can plug in all of our numbers there. And then we get, for that zone, okay, the attic uses 1,100 kilowatt hours. Wow, that's kind of on the larger side for January in this New York climate. And all right, maybe it seems large also because maybe the constructions that we've assigned here are actually maybe not the best. They're maybe not necessarily for a climate zone in New York. And I'll show you guys later how to change that. But you guys are at least beginning to get a sense. We can actually take this whole grafted list of heating too, and you'll see that, all right, we get the heating for each of the 15 different zones here, the mass addition of it. And so you can see, okay, the attic is just the most. I guess it's a very large zone too. Maybe that's why that happened. So what would actually be much more useful to see with this would be if we could normalize all the heating results by floor area. And there's actually a very easy way to do that. There's actually a Boolean option right on the import result. So you can import it with having it normalized by the floor area of the zone for you. So I'm just going to take up a Boolean toggle, set it to true, and plug it in here. And again, unfortunately, if you go with it this way, it's going to reparse the whole file, which can take, we already know it kind of took a while in our case. So I'm just going to fast forward for a few seconds. Okay, all right, that took about, let's say, 15 seconds or so. And now we see if we do this, now these results are normalized by floor area. And you can see that both in the header of the list, it's telling you now it's floor normalized and it's kilowatt hours per square meter. And now we have a kind of consistent metric to look at which are the zones that are really giving us the most problems in terms of heating. And it looks like the attic, even though it was using a lot of energy, the energy per unit floor area was actually not too bad. And we have much more worse zones like this one with the 19 kilowatt hours of heating per floor area. So you guys can understand, you can start to parse through the data and understand what's going on. But of course, what would be really useful is if we can now like really start to visualize this data, not just as like a block of numbers or, you know, or as a mass addition of numbers, but as maybe say like on a colored chart. And lo and behold, that is exactly what we can do with the Ladybug color chart. And the cool thing about essentially having the data in this format with this header and with the rest of this stuff is that it works with all of the Ladybug visualized data components. So you can like color suns based on heating on the sun plot, or you can make a windrows like that is based on the heating and cooling load of your building. You can really start to like actually visualize and get specific with stuff. But let's start with something basic for first. Let's just look at a 3D chart of the heating values, and let's see. I'm going to move this stuff up here. And let's just look at the attic zone's heating load. And if we take that and plug that into our 3D chart input data, you guys will see it'll take a second, but it's now drawn the 3D chart in our Rhino scene. Actually, I'm going to switch into top view. So I kind of find that a little bit more helpful. And all right, you kind of got our house there. But you guys can start to see, all right, there are time periods when our heating is worse than others. And it looks like it's, you know, it's particularly bad early in the morning where you have these higher values here. And I guess keep in mind that this is also kilowatt hours per meter squared. So if we didn't floor normalize, it would be different. And the thing is, actually, I'm gonna set some of my favored settings here. Let's see. I'm gonna do we'll leave the X scale as it is because we're looking at just January. If it was for a whole year, I would make the X scale smaller. But I'm going to set the Z scale to 0 so we can actually get a sense. We can see the lines of time there. That's a little nicer. Maybe we'll just put a custom preview on there. And so, all right, we can kind of begin to sift through this and see when, what are our worst heating times. And you can imagine if we ran the simulation for a whole year that we'd be able to see like, okay, what are the most problematic parts of the year where we have heating as an issue. But you can see that like generally afternoons tend to be fine. We don't need to heat our attic then, but it's in the morning, this critical time when we have a higher heating load. And we can do this, you guys don't necessarily have to do this on your machines because it will take a while, but I'm going to do this and fast forward just to show you guys. And you can plug in the results for all the zones, and then you'll get essentially a heating graph for each and every single one of those zones. All right, so guys, I know you don't have to do this on your machine, but just so you guys understand, I'm going to fast forward right now so we get straight to the result. Oh, gosh, yes, and I forgot one other very important thing, which is that if we want all of the graphs that are generated from this component to be on the same sort of colored scale that we have here, we have to connect consistent legend parameters before we connect up everything to run there. So I'm just going to drag and drop some Ladybug legend parameters, and maybe we'll take the high and low bounds to be essentially the same as what we have for the attic here. So, it looks like it's going from 0 to... up to, let's see, 0.05 kilowatt hours per square meter. And then, as long as we do that, I guess we could always put custom colors and a bunch of other things in there. But I think this is really all we need, just so that we'll have this consistent scale across all of the charts that we're going to connect to this. Okay, guys, and whoops. Lost it there for a second. Okay, so all right, so you guys don't necessarily have to wait through this whole part here, but I'm going to connect up all the zones here so that we can get a chart for each and every one of them, and I'm going to fast forward so that you guys don't have to sit through it. So there we go, it's connected, and I'll see you on the other side of the calculation. Okay, everybody, the calculation finished, and you can see what we get out of this is that we get a 3D chart now for each and every zone. And you can see, each chart has its the name of the zone in the title, and you can see that the energy use of each zone is very, very different over the course of January. And some of them, I guess a lot of them tend to have this need for heating right in the morning when people first wake up. But really, the attic really seems, if we zoom out over all of these, the attic was the only one. It seems to be a kind of peculiar case where it had this consistent need for a lot of heating up there. I guess we have a few other zones that are kind of comparable at these key times. Like these two over and around there. Oh, and I guess we have another one that's that's probably around here, whichever one zone 13 is. And you guys know that you can label them and sort of see which zones are giving you which problems at which times. But so this gives you a bit of a sense of the temporal resolution now that we're able to get, and understanding how things are changing over time in each of the zones. But what would be really awesome is also that if we can see the sort of spatially resolved, which zones are causing more problems than others at a given hour or something. And that's what I'm going to show you guys next, which is a sort of way to color zones based on these values of heating, I guess in this case. So all right, so let's do that. But let's see, I'm just going to plug back in our single zone because this is actually kind of slowing down my display, and just fast forward it for a few seconds. Or actually, we didn't need to fast forward it. All right, we're back to our single 3D chart there. So let's see. I'm going to turn the preview off on this 3D chart because we're kind of done with that for now. But but I should also point out, guys. I mean, I know we've been looking at heating, but you guys can take any one of these outputs. Like you can take. I mean, there's no cooling in January really, but you can take electric lighting, electric equipment. You can plot these things on the chart to understand how they vary over the time that the building is being used, because the lights aren't always going to be on. It's they'll be on when people are there, so you can really use this to get a sense of what's going on inside the energy simulation. But okay, but now to, as promised, let's look at coloring these zones based on that heating, so we get a kind of spatial sense of what are our most problematic zones in terms of heating. And you'll see under the 9 energy tab of Honeybee that there's a cool component called color zones based on EP result. And so I'm going to drag and drop that onto our canvas. And you'll see the input of this, it takes Honeybee zones, all right, and that should usually be the zones that you plugged into your simulation. That usually ensures that everything stays consistent. So you plug in those zones, and it's going to copy some of the data to your memory. So this component usually doesn't take too long, but the first time you connect up those zones, just wait a few seconds. All right, so we've got Honeybee zones, and you know what? Let's turn the preview off on this because we're gonna look at some pretty cool colors in a second. So you don't necessarily need to see that anymore. And let's color our zones based on the heating. So we'll take the heating results out of our import results component and plug it into there. And you can see instantly it sort of tailored the component to understand what was in that zone data. But you can plug in any one of these, and I'll show you some others in a second. But if we set a Boolean toggle to true for run it, you'll see that it will generate on the other side after a few seconds, a colored pattern showing us, roughly where the heating energy was most in our zones per square meter by default. This is useful to see the way it is now, but I have a kind of nice way of formatting this that I'm going to show you guys that you can't necessarily do with native Python, but I'm going to actually turn the preview off on this and bring up a custom preview component. And you see I give you the zone B-reps that come out of here, which you guys probably know already, what the zone B-rep is. And I give you colors that actually have a nice bit of transparency to them. So I kind of prefer to view my building this way rather than with those colored meshes. And if I do a Control-C again to Control-V to get another preview of these things, I'm going to preview the zone wireframe and the legend on another one. And I want to not use the same colors as that, but I want to do a swatch of black so that we can kind of get a nice preview. I mean, you guys will probably, you can customize this yourself. I mean, we kind of made this so that you can do your own types of settings. But now we can see, all right, what are our most problematic zones of our building for heating, of my parents' house for heating. And you can see, kind of not surprisingly, the worst one, or one of his worst ones, is on the north side of the house. So it's not getting a lot of solar heat really, and it's a one that's a kind of like as an appendage off of the house. It's got a lot of surface area that's losing through these walls and roofs and everything. And so you guys can kind of start to understand now what's going on in the model. You can see also it's doing this for the whole of January. It's the total energy per square meter for all of January, and it would be that same way for the whole year as well. And then you can also see that interesting things that even though these top zones are south facing, they end up losing a lot of heat energy to the outside through the envelope probably because they have a higher surface area than these other zones. And and of course you have a really high glazing ratio, and maybe that actually doesn't even help so much, even though you're getting a lot of sun through there. These rooms probably end up losing a lot of heat. But you can go through and see, so this is showing you the average of January, but you can also do things like going through step by step of your simulation. So I kind of have a slow computer here, but maybe if we just bring up a slider by typing 5, you can actually, and we'll maybe start with 1. But you can see, you can actually scroll through step by step of each simulation and see what the energy use of each zone is. So you can see when things are giving you certain problems. This is at 1 a.m. on the first step of the simulation, and I'm scrolling through it, and at a certain point the sun is going to start rising. And, well, actually, first you'll probably see the occupants wake up, and then you'll see a spike in heating, like, oh, things change at 6 a.m. when people start waking up. Different zones have different amounts of heating. And you see things start to change as the sun rises, the different zones have different sort of heating requirements. This zone doesn't have as much. And, and you can really start to get a sense of, like, what's happening dynamically in your model by scrolling through this way. And when the heating is more or less intense. And you guys see that you also have a legend par. You guys know from Ladybug how to use that. So you can make these colors your own. You can pick you can change the scale so that you can actually see, keep a consistent metric as you scroll through the hours of the year. But let's see, and as I said, you guys can take any sort of data and look at it this way. So if we wanted to take the operative temperature of the zones, if we wanted to start to look at comfort, you guys can see what the operative temperature is. And okay, this might make a little bit more sense to us. We see at 10 a.m. the zones on the east side of the building and the south side get this nice solar heat, and they're the nicest and warmest places to be in the house at that time. So that's probably where your occupants might want to be at 10 a.m. You can start to think. But you imagine at 6 a.m., let's see, well, or maybe deep at night, when the set points dropped, maybe at 5 a.m. before the sun's really risen, you see there's a different temperature distribution. Like the attic is the warmest because all the heat started rising to there when the heating set point was down. And and we could, I don't know, let's see if we wanted to go later in the day to 3 p.m. You guys would probably see that there's that more of the west side or more of the west and south side are now getting a lot of that heat. So you guys could really get a fine level of detail and understand your simulation. And you guys will also notice that if you do run an annual simulation, you can set an analysis period. So instead of scrolling through hour by hour, you can look at just January, just spring, just fall. You can color zones for any time of the year, and we give you a lot of freedom with this. So all right, so you guys get a rough sense of how you can start to visualize results. But the thing is, you guys, we've only looked at at zone level results. And the thing is, if you guys remember from the previous one, we requested surface temperatures. And in the next video, I'm going to show you guys how to look at those surface temperatures, because there's a whole sort of different workflow for those. And how you guys can start to parse those and understand them and work through them in the same way that we have here. So thank you guys for sitting through this one. I hope you guys are starting to see where the energy simulation pays off and this kind of stuff that you can get out of it. And thanks for watching. I'll see you in the next video.